Today we will see Java components and setting up Java. So good morning everyone. Everyone feeling active? Okay, let's start. I am Kumar Agarwal. I am currently working as senior software engineer at Amazon. So today we'll see Java components. So there are three Java components. We'll see that today, and we will set up Java in our system. Okay, I will just show the procedure how to set it up. You can go at home and try it. If you are facing any issue, you can put it on WhatsApp group. I will help you out. Okay, so we'll do this today, and if we get time, we will also see basic Java structure. So how the code looks, what are the important parts of the code. We will see all those things. So first, what we'll do, we'll revise what we learned yesterday. So we will do this in a question answer way. Okay. So how many of you have attended yesterday's class? Can you just put +1 in the chat, or you can just maybe tell yes, unmuting yourself. Okay, nice. There is at least one more. So what we can do is there will be set of 4 to 5 questions. You can just put your answers in chat, A, B, C, or D, whatever you feel is right, and I'll explain the answer, and we can revise like that. So it will help you to remember important parts of the everyday's lecture. Okay. So if I'll just put the chat here so that question is also visible. Yeah. Which of these paradigms is procedural programming paradigm? Can you just answer in the chat? So uh, there are two types of like two classification of programming paradigms: imperative and declarative. Under imperative, we saw two paradigms. Under declarative, we saw two paradigms. So one of which is procedural programming paradigm. What that means is it's like series. You are programming in a series of step-by-step instructions. Okay. Remaining options, modeling code as real-life objects. This is the object-oriented programming paradigm. Modeling code as pure functions. This is a functional programming paradigm. Nice, Aditi. Next, which one of these paradigm is declarative paradigm? So can you guys type the answer if you know? Okay, I will tell the answer. The answer is domain-specific languages. Procedural programming and object-oriented programming is imperative paradigm. Under declarative paradigm, we saw functional programming and domain-specific languages. Okay. Next, which one of these programming languages are compiled language? So, like, which one of these language is a compiled language? C++, Bash, or Java, or none of the above? Can anyone type the answer? It's a team chat, kya, which I'm not able to see. Okay. If no one knows, it's C++. Bash and JavaScript are compiled, interpreted languages. C++ is a compiled language. What is the difference? In compiled language, we compile the code first and then execute it. In Bash and JavaScript, it is an interpreted language. In interpreted language, we directly execute code line by line. Okay. And what is Java? Java is both compiled and interpreted. We will see why it is both compiled and interpreted today. Okay. Next, which one of these languages is a dynamically typed language? So what was typing? Typing was we must declare the data type before even running the code for each variable. That was typing, right? You remember it, guys? So can you answer? Anyone? Please interact. It's fun when you interact. Others will also get to know that no, uh, Java is not dynamically typed. Java is statically typed because we have to declare data type. So Python is dynamically typed here. Nice, Sujit. Yeah. So Python is dynamically typed language. C++, Java, both are statically typed. So statically typed means we have to declare data type before doing anything. Which one of these language is not a high level language? Not a high level language. That's very important. Yeah, you can enter. Nice, Aditi. It's assembly language. So Python, Go, JavaScript, all these are high level language because they provide more abstraction. We have seen that yesterday, right? But assembly language is low level language because it has very less abstraction. But it's harder for humans to understand. But these languages, Python, Go, JavaScript, are easier for humans to understand. I think we have brushed upon few topics we have discussed yesterday. You can also visit that YouTube video which was shared yesterday. And if you want, you can revise that. That will help you a lot. Next we will come to the activity which I had shared in your day-to-day life. So how many of you have thought about this? And how many can you name few code names of Java version in the chat, please? So anyone has seen any code names of Java version? So initially, when Java was releasing till Java 7, I think they have named few code names. Any one name has anyone seen? You can type it on the chat or you can unmute and tell. Don't feel shy. Anyone of anyone of you have thought about this? Okay, I will just brush up on few code names. You can just go and have research on it. So there is uh, the first version which was released for Java that was named as Oak. Okay, and there is a version named called Mustang. There is a version named called Merlin, I think. I'm not sure about Merlin though. So there are few code names. You can just go and have a look. There is a version name called Playground or something like that. So you can just have a look on that and understand about it, why they named. Just have a look on that. So remaining questions, what I will do is I will also give one or I have also thought about it. It's not like that it's task for you, it's for me as well. So I have thought about this and I will give you one example and I will also tell how you have to think about these things. Okay. So first, in your day-to-day life, take an example of task and try to think how would you do it with procedural programming, OOPS programming, and functional programming paradigm. Okay. So what I'll take an example of task. My example of task is teaching. Okay. Let's say I'm teaching Java course. The end result should be I am able to teach Java course. So how will I do with procedural programming? I will write series of steps. So first step is prepare the content. Second step is prepare the slides. Maybe next step is maybe prepare some notes if you uh, like want to specify some points. You prepare some notes. Next is join the Zoom call. Next is teach. Okay. So this is how it happens, right? This is procedural programming. In OOPS programming, what will happen? I will model myself as an object. I will model laptop as an object. I might model even presentation as an object. And I will write functions for them. Okay? So you have to think like that. You take any task and you think how you will model based on procedural programming, based on OOPS programming, based on functional programming. Functional programming, it will be like a pure function. Maybe I will ask someone else to teach. That can also be there. Like it's a functional. You don't know how you will achieve it, but you just have to use the functions. That's all. Like we have seen baking a cake example, right? So in functional programming, I might be right. Just prepare the slides. There is an automated way. Maybe I will give some AI. It will prepare the slides and give back to me. So for the same input, it will give same out. So that is very important in functional programming. Okay. So this is how you have to think. You take in some examples, it might be difficult to fit functional programming. Like teaching, it was little difficult, but procedural and OOPS you can always fit because procedural is just series of step-by-step instructions. So you know how to divide a task into step-by-step process, and then you can just program it in procedural programming. Similarly, in OOPS, you just have to think about objects, model them as objects, and write their functions. So this is how you have to think. Next, let's say if you are given a task of creating new programming language, what will be your choice? Statically typed or dynamically typed? Compiled or interpreted? High or low? Why? So my choice will be dynamically typed. Maybe see, Java is statically typed. Even I use Java a lot, but maybe dynamically typed because I don't have to write a lot of code. But some might prefer that if it is dynamically typed, it is hard for them to understand their code after 5 days. So since Java is more readable, they might like statically typed. So it is your choice, right? What do you like? How you like your code? All those things, right? So I might prefer dynamically typed. I might prefer compiled because it's fast. Interpreted, it's very slow. I might prefer high level language because I can understand it. Obviously, low level language it's very difficult for me to do. But some people prefer low level language because they are habituated to it and it's very fast for them. So it's on your choice, right? But you have to think what you like. So when you start coding in Java, you can think these questions. Key whether yeah, I'm statically typed is for me. Dynamically typed won't work for me. Yeah, like that you can think. Okay. So this is how you have to think. This will improve your creativity and this will also help you like these are the tasks I am giving you so that you think or you can just google it and come. It's not like you cannot google. You just learn about this will help you to research a bit. This is what it will help you in future organization where you might given a task and you will learn how to research on it. You will learn how to answer it. Okay. So I will have think about this for most of the lectures. Some lectures it might not be there. Okay. So you please take a note and start thinking about it. Okay. Now we will start today's lecture. Okay. We will go through one Java syntax and tomorrow we will go through like proper demo of Java. So you will see how demos are also being shown. It's not just slides every time. But I have to cover basics today and I have to cover setup because if you get time, you can also set up and you can also learn when I show you the live demo. Okay. So what we will see today, we will see basic Java components, which is JDK, JRE, and JVM. We will see what is an IDE. We will see how you can set up your Java, how you can set up your local environment, and we will see basic Java program structure, and then we'll conclude. Okay. So first, let's revise what is Java. So like any programming language, uh, Java is also a programming language. It lets programmer write once and run anywhere. Vora, which this is what we will discuss today in depth. Write once, run anywhere, and why Java is the language that helps you do Vora. I'm not sure if other languages support, but C++ doesn't support Vora. Python is not Vora. So these languages are not platform independent. Okay, but Java is a platform independent language, which is Vora. Write once, run anywhere. Okay, first we will see what are basic Java components. So there are three components: JDK, JRE, and JVM. These three are the components that people mostly confuse with and might get caught in interview also. So please listen to this carefully. So JDK, think of this as a complete toolkit that provides tools and library for your development, for running Java application. It is a complete toolkit. Okay? And Java runtime environment. This is like an environment that will help you run Java applications. It will just help you run Java applications. You would have built some application. Let's say I have built some application and you are given a task to run it. You can use JRE. You don't have to use JDK. Okay. You can install JRE separately. JDK, sorry, JDK is not necessary that you have to install. You can install JRE separately and you can run your Java application. Next is JVM. JVM is virtual machine. It's kind of a machine. This is that component that interacts with your computer. Okay. So it will tell ki ha do this. It will convert that binary part like what we discussed yesterday, right? When the code runs, your code gets converted to binary. So that part is done by Java virtual machine. Okay. So this was whatever I have told. These were high level definitions. Okay. Now just see this diagram. We will understand this in little detail. So JDK contains JRE and JVM. It is not like JDK is a separate component. So JDK contains JRE and JVM, but it contains other tools as well, like Java compiler, debugger, and jar. So we will see this in some time. Okay. Similarly, JRE contains JVM. Okay. So it is like you can understand from the circle, right? JDK contains the full package. It's a complete toolkit. JRE is just for running. So it contains JVM, but it contains some other runtime libraries, Java API, and class loader. JVM contains its own component, Java interpreter. That's what interprets your Java code and sends call to machine, like converts it to machine code. Next is JIT, just-in-time compiler, and garbage collector. So these are few components. Don't worry about these components if you're not able to understand the name. But yeah, we will see this in detail in our Java course. So this is how the structure looks. JDK contains both JRE and JVM. JRE contains JVM, and JVM is a component. The hierarchy is like this. Okay? So we have seen the definition. We have seen the basic components. Any doubts in this? I'll pause for a minute. Any doubts? Okay, I think there are no doubts. So let's see what is JDK. So JDK is a software development environment. So JDK, the name itself has development kit. That means it's for developing. Okay, it's a development environment used for developing Java application and applets. It contains tools and libraries necessary for Java development. So it's helpful for Java development. But it contains JRE and JVM. If when you install JDK, everything you get everything as package. Okay, so components of JDK, I have written first JRE and JVM because like you should not confuse with it. So it is used to run Java applications, JRE and JVM. Next, it contains lot of components, maybe 10 to 15. I don't like I'm not aware of all the components it contains, but these are few important components which you might use. One is Java compiler, which is called Java C, used to convert Java code into bytecode. So you write your Java code, it will convert that into an intermediate code which is called bytecode. Don't uh, don't worry about this term. We will see this in detail. So this you write a Java code. In every language, whenever you write a code, right, it will have some extension. Like Python has .py file, right? C++ has .c. Okay? And C has .c, and even C++, I think, and I don't remember. And maybe Go has .go, JavaScript has .js. So similarly, Java has .java files. We will see that in demo today. So you will write your code in .java files. That code this compiler will take. Compiler is the tool that will take this Java code and convert it to bytecode. So when you compile your code, complete code, it will convert this Java code into bytecode. There is Java debugger. So it will help you in debugging Java programs. We will see how debugger works maybe this week or maybe next week once we have some idea of Java. So it will help you debug Java programs. So how it will help? You can put, let's say your code is failing, but you don't know where it is failing. You can put multiple checkpoints using debuggers, and it will stop the code there, and you can check whether your code is working filed in there or not. Okay, you have written like series of 10 steps for running, but after 6 step it's failing, but you don't know it is 6 step or 7 step or 5th step. So you can debug step by step at every step, and you can put a checkpoint and check whether the code has run till that or not. That's how it helps. Java debugger. Next is Java archive tool. So what happens if you have lot of Java files? This tool will help you to convert into a single jar file. We will see what is jar file in future lectures, but yeah, this is that tool. So JDK contains JRE and JVM and lot of other tools that will help you during your development. So these are all the tools that helps you during your development. When you compile the code, you can debugger is for debugging your code. Packaging, this tool is for packaging your code into a jar file. You haven't run your code yet. This is used to run the code, that I agree, but remaining components of Java mostly is used for during development. Okay, next we will see JRE. Any doubts? ठीक है. Next is Java runtime environment. So Java runtime environment is a software package that provides necessary libraries, that provides Java virtual machine and other components. There might be other components to run Java applications. It does not include development tools like compilers or debugger. So this can be installed separately, and it does not include those compilers and debugger. Those are present in JDK. Okay, so components of JRE, JVM, executes Java bytecode on any platform. Okay, core libraries. There are some other libraries, java.lang, java.io. There are a lot of other libraries. These libraries are present in JRE. So provide essential classes and interfaces for Java development. So these are defined libraries. We will see few of these library because we might use some functions from there. So we will see these libraries in maybe future lectures, but these are some libraries present in Java runtime environment. Okay. Next is Java class loader. Okay. This is also a component of JRE. What it does, it loads all your classes at runtime. Okay. So whenever it loads, it will help JVM to run those classes. So that will help you to run the code, right? So these are few components of JRE. Okay. Any doubts in this? Hello. Any doubts? Am I audible? If you don't answer, I feel no one is listening or no one is understanding anything.
Yeah, no doubts here. Please go ahead. Yeah.
Yeah. Thank you. So next is JVM, Java Virtual Machine. It's like a machine that enables you to convert your code to machine code. Okay. That interprets everything. That is the code that interprets everything. Okay. So Java Virtual Machine is a virtual machine that enables computer to run Java programs. Okay. So components of JVM, it has some bytecode verifier. So you compile your code and you converted your code into bytecode. Okay, that is intermediate code, bytecode. Now what JVM will do, it will have to verify whether that bytecode generated by you is correct or not. And it will check whether its security is correct or not. It's not doing something that's not allowed to do. It's not accessing a file that you're not allowed to do. All those things it will check. Next is Java interpreter. So there is a Java interpreter component. This is the one that executes your bytecode instructions one by one. So Java has Java compiler, we seen in JDK, and there is a Java interpreter. So that's why Java is called both compiled and interpreted language. So what it does is it is giving you benefit of compilation. It is also giving you benefit of interpretation. Okay. So it is like executing. It is converting into. It is not directly converting your source code to machine code. Compiler is converting your source code into bytecode, which is an intermediate code that is interpreted by Java interpreter line by line. Okay. So since there was a Java interpreter that is interpreting instructions at line by line, if there was a function defined, what we'll see what is function. Function is like a maybe let's say add. Add is a function. You just give two numbers, it will add and give. Okay. So function is like that. You can define functions in Java. So if you call that add function 15 times, this Java interpreter has to interpret that add function 15 times. So to optimize this interpretation part, Java people have built just-in-time compiler. What it will do, it will interpret that function once and it will store it. So converts byte into native machine code at runtime. So it will convert those repeated bytecode into a machine code and it will store it. So next time that function call is come, it doesn't have to interpret, it will just use that machine code and run it. So these are different components. We will see during the lectures when we come to that phase, we will understand most of the components in detail. It's not that you will not understand. I'm just giving a brief overview of differences. So whenever you are asked in interview what is difference between JDK, JRE and JVM, you can just highlight few points like JDK is for development, JRE is for running application, Java virtual machine is that machine that interacts with computer. You can tell few examples of components which are present in JRE, which is present in JDK but is not part of JRE, like compiler debugger. So that's why I have explained an overview to you. Any doubts?
Yeah, here security of bytecode, right? What is the major use of the security of bytecodes?
So it's like it will check whether you're some access level issues. If you are reading a file but you don't have access to it, all those things it will check.
Okay,
Understood?
it's like a SQL injection type or
No, no, no. It's just it will verify whether your bytecode has all access correct or not. Uh, and like it's
okay. No, no. Do we need to check any runtime errors using the
no,
security
no.
of
It is
bytecode?
it is not checking runtime error. Correctness will do that. So correctness will do like that. So it can be, let's say you what you will do, you are developer, you have developed your code and compiled it in your machine and created a bytecode for others to run. Okay, but what it
Okay.
can happen, you are circulating that bytecode, but someone did some changes in bytecode and circulating the wrong bytecode. So this bytecode verifier might also verify that whether the bytecode is correct, it is not some malicious, or people are not accessing things that they don't have access to. So what can happen is
Okay.
if you're circulating the bytecode, people might add function that will access your secret files and it will send it to them. Anything can happen, right? So
Okay.
all this,
Here, bytecode, right? Bytecode refers numeric or alphanumeric. What type of bytecodes here?
it is an intermediate code generated by Java. I will explain little bit in the next slide, but we will see that more in detail in future classes. So it's like a dot class file generated by Java.
Oh, okay, fine. Yeah,
So
got it.
and it is intermediate instructions only. From
Hmm.
whatever we have written, it will generate those intermediate instructions that is easily understood by JVM and it executes the code. Okay, in the next slide only you will see. I will just go to next slide. If anyone else have any doubt, I will uh, take that question as well.
Okay, thanks.
Okay, we'll check the next slide. Then I think you will get the picture clear. So how is the journey from source code to your machine code? Okay, this is what this slides will explain. So you will have your Java file. Okay, you will have .java file. This is what you will code. You might have multiple Java files. It's not that much big issue. You have .java file. Okay, you can run command java c compile your .java file. Okay, so that java c compiler will compile your .java file and produce the dot class file, which is a bytecode. Okay, so this compiler job is to produce that bytecode. It will go through your code and it might what compiler will do, it might check for type exceptions. So for example, you have written int maybe integer a equals 5. Okay, but in the next line you have written a equals zero point 0.5. You are trying to assign float to an integer, then this compiler itself will raise that error. It's not possible. So at this step itself your code will stop. So few of the errors can be caught here itself. So that's why .java file is compiled to .bytecode, .class file, sorry, bytecode. So this .class file, you can use it to execute your Java code. You can circulate it, or you can just there was a tool called jar, right? We have seen in JDK. You can create the jar and circulate the jar. Lot of applications, Java applications you see online, you will see you can please download the jar for running our Java application. Like that you will see. So they create the jar and circulate this for others to run. Okay? Even if some software package is there that has to be run on your computer, when you install that software, it will install JDK and it will download the jar file and it will run that jar file. Okay? Now what JRE will do, JRE will load all the classes you have written. We will understand what is class in depth, but yeah, you can think class as a different components of code. Okay? It will load all the dot class files and it will load all the classes. And once it loads all the classes in memory, this interpreter and this just-in-time compiler we have seen in that will interpret this bytecode line by line, and it will convert into machine code and give instructions to machine to run your Java application. So this is the journey. So if there are like multiple function calls, just-in-time compiler will optimize those and convert it into machine code and keep it. Whenever that function is called again, it will use that machine code and it will execute the program. You don't have to like this is like just a optimization. Okay? Any doubts? I will tell one more thing. So this is not like complete steps. There are a lot of intermediate steps that is happening. We will see that in detail once you know a bit about Java. So once you have knowledge about classes, objects, all those things, we will see some architecture, how JVM works, all those things we will see. So don't worry about that key you're not understanding in the first class. These are like high level things. Just read about a bit, read about it uh, by yourself. Try to understand. If you're not understanding, message in the WhatsApp group. I'll reply. Okay? But don't worry ki you won't understand because it's too complex. We will see this everything in detail. So compiler's job is to convert into bytecode in case of Java. In case of C++, compiler will directly convert into machine code. Okay? So compiler jobs here is to convert it to bytecode. Now in JRE, JVM, there will be a bytecode verifier that will verify this. That step I haven't added here. But there will be a bytecode verifier that will verify these bytecodes. It will also verify that if someone has not modified it, whether the bytecode hash or maybe whatever, however it verifies that whether the bytecode is correct. You are not accessing things that you don't have access to. All those things it will verify. Then there will be a class loader. There is a just-in-time compiler. There is an interpreter, and then machine code. So it will call some libraries in machine that will execute your code. So this is how the life cycle of your code looks like. This all happens in an instant. You will never know key what is happening. So when you run the code, you will when you compile the code, you will see it's like very fast. But if you have very huge code, that's different. But yeah, I will just run one code and show you today. There is one component which I forgot to add, which is garbage collector. It is present in JVM. That is for memory optimization. We will see that later when we are seeing JVM in detail. Okay, so that's why I didn't add this. So next is this is the important question we are trying to answer. Why did I tell you about JDK, JRE, and JVM so much? Because we want to know why is Java platform independent. From the first thing you learn in Java, everyone will tell Java is platform independent. Java is portable. You can use it anywhere, compile it anywhere, and run it anywhere. Lot of people will tell, but why? So, one thing I'll tell is Java virtual machine is platform dependent. It is not platform independent. So when you install JDK, when we install JDK, right, I will show you a demo. You will see for each operating system, you have to install separate JDK. That means JVM is different for each operating system. So first, let's understand what is platform independent. Platform independent means in this slide, right? Platform independent means you can compile it anywhere. Let's say I have written the Java file and compiled it in Mac. I can run it on Linux. I can run it on Windows. I don't have to worry about it. But in other languages, let's say C++, you will have to compile your code again in Linux. It is not possible for you to take the compiled code in Windows and run it in Linux. So why platform independent is necessary? Because in an organization like a very big organization, some people will have Windows, some people will have Mac, some people will have Linux. It's based on how organization decides, right? So maybe developer might get Mac, maybe, and maybe other people who are running the Java code might get Windows. Okay, or you are selling your Java application, but you have developed in Mac, but the buyer can execute it on Windows or Linux. So you might have, if your code is not platform, if your language is not platform independent, you might have to sell different applications for different operating system. So that's why Java helps us. So you will have to just develop once. You don't have to develop for multiple operating system. You don't have to develop for like you don't have to compile multiple times and maintain multiple compiled versions in your website. Okay. So if you are selling a Java application, you don't have to worry about that, whether it will run in our system or not. Okay. So that's why platform independent is very important. Now let's understand. I hope it's clear. Anyone has any doubt on what is platform independent meaning? Meaning, what is meaning of platform independence and why platform independence is important? Anyone has any doubt? Okay, I will take that as no doubt. So let's see now why Java is platform independent. We have seen that JVM is platform dependent because you have to install different JVM. So since JVM is platform dependent, that means every operating system has its own JVM. For Mac, it will be different. For Linux, it will be different. For Windows, it will be different. In case of Java, it is a magic of bytecode that is making the Java platform independent. So you compile that bytecode. Now that uh, it is like in this step, right? You compile the bytecode. Now this bytecode can be interpreted by, let's say you compiled it in Windows. Okay, you have that bytecode. You put it on Mac. Now this bytecode is written in such a way that it can be interpreted by any JVM. Okay, it can be interpreted by JVM present in Mac. It can be interpreted by JVM present in Linux. It can be interpreted by JVM present in Windows. Now, since the JVMs are different, now Mac knows how to call Mac hardware, maybe machine code. So it will convert into different code suitable to run in Mac. And similarly, since JVM is different for Linux, it will convert into different code that is suitable for Linux. So this is that magic happening that makes Java platform independent. Okay, JVM is platform dependent, but Java is platform independent. Okay, so every system understands the same bytecode in its own way. This is very important because of different JVM that is installed in. Okay, this is what I have explained. So what Java developers have done, they have made JVM platform dependent, but that made Java platform independent, which is called ORA. ORA is write once, run anywhere. Okay, any doubt? Any doubt? I think if you are asked in interview why Java is platform independent, will you be able to explain? Okay, you just have to mention these points. You don't have to go through depth key, what is JDK, what is JRE, JVM. That is for you to understand. Okay, you just have to mention that JVM is platform dependent. We have separate JVMs for separate operating systems. But bytecode can be understood by each of those JVM. So each system understands the bytecode in its own way. This is very important because of different JVM that is installed in that. Okay, so this is how you have to explain. Two of the important questions, important interview questions we have seen. today. What is the difference between JDK, JRE and JVM, and why is Java platform independent? Okay. So people might use why is Java Vora? The answer is same because write once run anywhere. People might use why is Java portable? So there is a term called portable also. So don't get confused with different words. The answer remains the same. I will just proceed. Any doubts, please stop me. Let's keep it interactive. Okay. So next is set up Java in local. What we have seen till now, yesterday we saw programming languages. What are programming languages? We classified into many types. We saw programming paradigms. We saw what is Java. We saw history of Java. Today we are seeing components of Java, JDK, JRE, JVM. And we saw why Java is platform independent. We have seen this much till now. Now what we'll do, we'll set up Java in local. So like I will explain the steps, then I will show you small demo also. So first is you'll have to visit this site, Oracle Java Technology Downloads. Okay, based on the version you want to download, you can download that version. So if you want to install older version, so there are some versions present already in the site. But if you want to install some older versions like Java 8, you can use the download from Java Archive. So there is a tab called Java Archive in the above link. I'll show that also. So based on your system, Windows or Linux or Mac, and also architecture is also important. There's ARM architecture, there's x64, there's x86, like that. There are different architectures for your machines. Okay, you have to download the appropriate JDK. So it depends on different things. Just check which JDK you have to download and download the appropriate JDK. Now install the downloaded file on your system. Maybe if it is a .dmg file for Mac, just click on it, open it, install it. And similarly, if it is like a .exe file for Windows, you can just download it. Okay. Now, while you're installing, you will see the path in which it is getting installed, the JDK. Okay. You will have to export a path environment variable, and also there is one more environment variable, Java home, Java underscore home. You will have to export that, which is equal to bin folder of installed Java. Okay. So this path, I will show that, don't worry. And once Java is installed, go to your terminal, just type Java minus version, you will see the info, or Java C minus version. That is to check if your compiler is also installed or not. Okay. Now let's see this, that the website I was telling you, right? Java downloads. This is everyone is able to see this browser, right?
Yes, Kumar, I have one question. Whether
Yeah.
SAP supports Java?
That I don't know. I have to check. I will have to check that SAP. I haven't used that.
Okay, okay,
Yeah, I will check and come back.
okay, Kumar. Yeah, thanks.
Yeah. So if you go to this website, you will see Java JDK 22, JDK 21, and 17 versions. Okay. You will see for Linux they have given some download packages. For Mac you will see some. For Windows you will see some. Okay. And next is Java Archive, which I was telling. You just have to go here and click on the version you want to install. Let's say you want to install Java 11. Just go through Java 11 and you will see everything for Linux, for Mac, for Windows. And you will also see different x86. I don't know, like ARM, x64, ARM, x64, like that. Okay. So you can install based on your requirement and you can install them. Okay. So one thing I want to show is when you go to this, there are different Java things, Java SE, Java EE, Java ME. Like, let's not worry about Graal VM and Java FX. But these are three important things. We will see that in next one or two slides. Okay. So let's download a Java version. So mine is a Mac. What I will do is mine is ARM because it's Apple Silicon Wala thing. I'll just try to download this. So it's downloading. Till then, let it download. You will see an installer like this. ठीक है, just have to continue. Install for all users for this computer. So install location, change install location if you want. No, you have to just install. You will have to ensure your password like that. So you just have installed and you are just moving the installer to bin. Just open your finder. So if you see, you will see it is Java is installed, Java 22.02, which I have installed just now. And if you want to see which Java, in Mac, I don't think we have to export some path. If exporting path is just for some different tools, if you want, you can export it. But without exporting, you will see it is installed in this path, user bin Java. Now you can see Java C minus version. This is 22.0.2. So these are the things you can download and check. You have seen, right? I have downloaded this. Where is that version? 22.0.2. Okay, this is the version I have downloaded. Now you can see Java version 22.2. You can tell Java runtime version. There is something called hotspot also. But yeah, and which Java will help you see where it is installed. Now you can just go through the directory. If I have access, I'll just check. So that's a just Java file. Okay. So this is how you install. Okay. For Linux, you might install and you might see the path, and you can just export that path and home Java home. So if you just see, you will have to export like this. Path is equal to like this, whatever the path to the bin folder, and export Java home. Okay. And we will see this when if anyone is facing issue, I will help you out. That's not a problem. And in Windows, exporting environment variable is little different. So for Windows, I will give you a site. You can visit that site and take the help of it and then export the path. Now let's see this. So based on your system, install. So we have done this. Install the downloaded files. We have done. We have clicked install, right? And to check if Java is installed, use Java minus version and Java C minus version. Okay. I think if you have your laptop, please try this today. If don't, it's fine. If you have your laptop, please try this today and install any version of your choice. Maybe you can install 17 or maybe 21, 22, any version of your choice. Next, I have shown that there is a something called Java SE, EE and ME, right? So full form is, sorry, drink water a little. So we have only half an hour left. So Java SE is standard edition, Java E is enterprise edition, and Java M is micro edition. So we installed standard edition. So it is good starting point for learning Java. It is used to build basic application. For all Java applications, this is important. Okay. So in enterprise, they have added few more things which is used to build complex application. So it can be used to build web application servlets. This enterprise edition might be required. And micro edition, it's used to build applications for mobile devices. Okay. So everything is taken from Java SE only, but these two are little special for complex application. This is for mobile application. So it contains its small virtual machine that can be run on mobile. And there is an API that is subset of this only. It's not, it doesn't complete everything of standard edition, but it contains some subset of SE. Okay, this micro edition, it's for mobile. So I mentioned this because when you're downloading, you shouldn't get confused. Please, for the class, I think standard edition is enough for few lectures. But if at any point enterprise edition might be required, I will just check and let you know. Okay. Please try to download today and install it on your computer and check if your download is complete or not. For Windows, I will share the link in WhatsApp group. Now let's see you have downloaded Java. Now how will you code? So there are few ways. You can write your code in any text editor. Okay, just open Notepad, your code, save it as .java file, compile it using the Java C command which I was showing you, and run using Java command. Okay, that you can do. That is one way. Okay, next one, another way can be there are online Java code runners. You can just you can just refer to the website and write your code there and run your code there. But what people are using in current organizations are IDEs. IDE means integrated development environment. Okay. So this is like an environment in which you can develop your Java applications. There can be multiple files. So if you are using Notepad, let's say you have to maintain multiple files, you don't know what directory contains what code. Let's say if you're calling a function maybe from some other file, how where is that function? What is the definition? All those things, it's difficult to navigate and it's difficult to do. So what different companies have created, they have created an integrated development environment. So it is like a software only. It might be written in Java also. So it's like a software that provides comprehensive facilities to computer programmers for software development. It's used for software development. So it has abstraction, what we know, right? We don't know how things are being done. So it has abstracted your running thing. You don't have to run, compile, run command, all those things you don't have to do. It has abstracted your debugging. You don't have to use run JDB command to debug, put checkpoints like that. Okay? You can put checkpoints in the development environment and do it. It has it has abstracted JVM. You don't have to worry about a lot of things. Okay? And even jar utility also, I think you can use IDE to build. Okay? So it integrates several tools in a user interface. It is giving you a UI to do that. Sometimes even Git also you can do using these are few IDs. So you can write your code, test your code, and debug your code more easily and more efficiently. So this is an IntelliJ provided by JetBrains company. This is for Java. Okay. This is Visual Studio Code. This is Eclipse. All these are for Java. Eclipse is more popular for Java, but I prefer IntelliJ. It's your choice. Okay, I will just show how to install IntelliJ, but you can use any of these three. And next is PyCharm. PyCharm is for Python. This is also provided by JetBrains. JetBrains companies have provided different tools for different programming language. Okay. Any doubt in ID? ID is integrated development environment. So and like developers nowadays are so habituated to IDE, like debugging locally running file that will be a nightmare for them. Okay, because ID is so abstracted. You don't have. We will see one example code today. From that itself, you will understand. Any doubts in ID? Now let's see one last thing: how to set up IntelliJ ID. Okay, you will have to go to this site, JetBrains IDEA download, and there are two versions for it. IntelliJ. One is Enterprise Edition and another is Community Edition. So Enterprise Edition is paid version. So Enterprise Edition has multiple features on top of Community Edition. Okay, and what you can do is for the class you can download the Community Edition for your operating system. So it is same as the JDK. What you do, you have to select which operating system you want to install for. But in the website, I think it automatically selects based on your system. It will automatically selects what you have to download. So install the downloaded file on your system. Once you install, open the application, check if it is installed or not. Okay. So if I just go, sorry, to this. Okay. This is the website. Once you go to the link which I have provided, you just don't have to go to just the link. It will automatically select you are in Mac. Okay. It is automatically selecting which file you have to download. But if you want to download other file, you can download other also. So sorry, you can only download the files for which you can select operating system here. I'm really sorry. So you can download for Windows as well. You can download for Mac. You can download for Linux. But based on my operating system, it automatically selects what I have to download. So this is that ultimate edition, that enterprise edition which I was talking. and this is community edition. So don't download this. It will be just 30 days free trial you will get, but after that you will have to pay for it. Okay, you can download this, and once you download and install the same way which I did for JDK, you will see IntelliJ. Just open the IntelliJ. If you are facing any issue, let me know. So I will just show IntelliJ. So this is how IntelliJ will look. So you can see I have a directory created, something called Java course. This is a project I have created, and you can, if you want, you can create new project. Okay. From maybe if you want, if you already have some code, you can create from existing files, or if you want directly how to create, you can create a new project. Okay. So I have created this Java course thing, and once this project is created, once you create a project, it will create this form.xml. So you will have to specify which project you have to create. Based on that, it will create. If I have selected Maven project, let's try to create one project. That will be the best. Let's create Java class. Let's say courses from Java class. Okay. I want in Java. I don't want in other languages. Okay. I don't want IntelliJ build. I want Maven build, and I want grade. I don't want Gradle build. Okay. You can select your JDK. So it is giving me both JDK. I had 11 installed before, and I have installed 22 right in front of you. So you can select which JDK you want. Let's say I have selected 11. And if you want to add sample code, you can add and just create. Okay. Would you like to open this project now in this window or new window? I'll just select new window. Okay. Now Java class project is created. Okay. So Java course project is here, Java class project is here, and they have created some sample code for you. Okay. And they've also created this form.xml. We will see what is this in greater detail. And they have created some other folders as well. So this is for testing. If you want to write your unit test cases, we will see later. Okay. So this is your main file. Okay. Now let's see one sample program. Okay. This is your sample program, Java basic syntax, how your program will look. Okay. First thing in your Java file, you will see package, which package this file belongs to. I'm not sure if it is mandatory to specify or not. I'll just check that and get back. But this is the package part. We will explain what is package. Don't get on to the number of words which is shown here. We will see what is the meaning of word public, what is meaning of word class, everything we will see. Don't worry about it. I'm just showing the structure of the code, how it looks. Okay, just to get the feel of it. Okay, in every language you learn, first thing what you learn, hello world. So hello world program that will say why people uh, started telling hello world program, because that will show you the structure of the code. So how the code will look, how you can compile. It is just one line code. See system.out.println hello world. In C++, it might be C out something hello world like that. Okay. In Python, it's like just it will be print hello world. So what it will enable us? It will enable us to see the structure and how to run that code, how to compile that code. All those things we can understand just by a simple structure. Okay. So let's see the structure in the uh, IntelliJ itself. So we have a source, we have a main, we have a Java folder. So this is that path. This from this Java, I have this java.org. This is the package. So this package, sorry, org.java. Sorry, not from this Java. This org.java. This from this the package is starting. If you see that circle, right, from there packages start. So if you mention org.java, it is present under org.java, this file. Okay. Similarly, for the files present in this part, you will see for, let's say I will open, there will be operators here. Something we have done. So you will see org.java course because it's under Java course. Okay. This is just the structure. Don't worry about it. What is package we will see in detail. Don't worry about it at all. Okay. So this is the package file. Package file will show which directory your code is belonging to and some other details which you will see what is package and all. So every code in Java is present inside class. Okay. So you will have to define class for it. Okay. So this is how you define class. So we will see what is public. You can use multiple other modifiers like private and protected, but this class must be public. The first class which you are seeing must be public. Okay. And one class, at least one of the class of your code will contain this main function. Okay. This main function is the entry point of your code. Main entry point means that is where the code will start. So whenever you compile your code and JVM is trying to run it, first what it will do, it will find the main function which you are running, what main function you are running. So even when you provide the command to run, you will have to specify main class file, which main class file you want to run. So you can have like multiple main class file in your system, which main class file you have to run. I will show that also. Okay. So once you specify that class, it will find that main function and it will execute that main function. Okay. So in main function, you might call other class, you might call other function, whatever you do, but it will execute. Okay. So this is the structure. Don't worry about this static, void, public, all those things. We will see in next 2-3 weeks. We will go over each of these in detail only. So this is the main function. Function is which I told you. It's similar to add. You just give some input, it will give some output. Okay. So you can call this. The JVM will call this main function, and it will run that execution. So arg is here what you pass arguments when you run your Java code. So you might pass the uh, uh, my one of the argument is 1. Okay. In the code you might see you can take an argument, tell enter student's roll number, and based on roll number you can print the marks for the student. Let's say your Java application does that. Your Java application takes student's roll number and it will print what it will print. It will print the marks of each subject of that student. So while running your Java code, you can provide arguments. I will show that in how in IDE it works, but you can provide arguments, and based on that argument, your code will run. Okay, so that is what this arg is. See, now when you are using an IDE, the difference is you will see highlighting, right? You can see different highlights. So some keywords that is used by Java are highlighted like this. Functions are like highlighted like this. Okay. Now, if you have to navigate to different files, you can navigate like this. Okay. You will see a lot of other functionalities of IDE, but yeah, it's very useful. And if you want to see documentation of it, you can see a lot of things about it. Change access modifier, do a lot of things. So it provides a lot of other functionalities apart from this. Okay. And let's try to run this. Okay. See, you will see hello world printed. Okay. So this print ln is used to print in the console. Okay. You will see it's using the 11 JDK version and it is running this command only. Okay. Finally, it is forget about these things. It is providing the class path where my class path is, and it is running this org.java.hello world. This is what I have to run. Okay. This class path is this path. Okay. Okay. Target classes. We can see even that class file being created. Classes. Just go to your org.java file. This is that class file. Okay. But once you access it in IDEs, what it will do, it will convert your class file back to .java file and it will show to you. It will show the same code to you. That is called decompiler. So it is asking me permission to enable, maybe like that. So even if I accept, it will show the same. Okay. It has created some other, it has added some other code of its, some maybe some comments or some public hello world which was not there, but it has done as per its own part. This is decompiled dot class file bytecode version 55.0 Java 11. You can see that this is dot class file. It's not Java dot Java file, but it's decompiled so that I can understand this. It's not like bytecode will do by this is the bytecode. It's not the bytecode. It is just decompiled dot class file so that I can understand what is there present in this. Okay. So actual file is this. It has added some few things. We will see that in detail later. But yeah. So you will see target classes, everything, and your hello world is printed. So this is the command that this IDE has run. Okay. It is running Java command to run your Java code, and it is printing this hello world. Process finished with exit code 0. If it is exit code 0, that means it didn't fail. Okay. Now what you can do, you can print other things if you want. System. So if you're just see the power of IDE. If you're just writing system, it is helping me. If I just put out, it is helping me out. There is out. If you just dot put, you will see what are the functions you can do. But you can't do this in other files, right? IDE helps you a lot in development. Or you can just select the function. It will just type it for you. Don't have to type even colon for this, semicolon. Okay? You can write my name is Kumar. Okay? Okay. One more thing, see the syntax also. Just notice the syntax, it's curly braces. So everything opens with a curly braces and closes with curly braces. And every statement ends with the semicolon. Okay, this is requirement. If I just cross this, it will show some error. In red, it is showing, right? Semicolon except expected. Okay, insert. If you just click on insert, it will insert. So that's the power of IDE. Okay. Now system.out.println. Again, you can write system.out.println. Welcome to Java course. Let's say I don't know how much time is left. Okay, just run this. Hello world, my name is Kumar. Welcome to Java course. Okay, so this is how you print. We will see why system.out. We will see that. Don't worry about this wordings. Okay, but just note, take in go in your mind. Just keep. This is how the structure looks. The important points you have to remember is this is the structure. This is how the entry point looks. All those things. These are the important things you have to take. Any doubts? Any doubt in this? Any doubt in this basic syntax? Okay, tomorrow it will be full demo. I will use maybe 2 or 3 slides or 4 slides maximum. Okay, it will be full demo.
Okay.
Any doubts you have? Okay. What I will do is, let's recall what we have learned first. We have seen basic definitions of Java components. Each individual component, JDK, JRE, JVMs, we have seen what are the components present in it. Just remember that circle. So JDK contains JRE and JVM. JRE contains JVM. So that remember that circle. That is very important. We have seen what is ID. We have seen Java, SE, ME, E, all those different versions that has come up. We have seen also, I see some message in chat. Okay, I will explain this. Mm, so there are two things. One is Java application and one is applets. So we will do applets also in Java. Sorry. Yeah. So there are two things: Java applets and Java application. Okay. So applets are like a special kind of Java program. We will see that in detail maybe next month in next month course. But overview, if I have to give, it's like you can download applets from internet and run. Maybe it's for circulation. It might be it is little different, special kind of Java program. And the important part is applets can run inside web browser. Okay? That is why applets are used. It is not like an application that runs on your system. It is kind of embedded in web browser. So we will see that in detail. Don't worry about it. Yeah, so we have seen what is ID. We have set it up. Please try this. Uh, just in this, these are like simple steps. I will provide link for Windows and I will also provide link for Linux. For Mac, I have shown, and the Mac also it will be present. So I'll provide link for all the three in the WhatsApp group, and then set up your local environment. You can use Eclipse if you want. You can use Visual Studio if you want. You can use, if you are using already using one of these three, please don't install IntelliJ just for the class. You can use your own IDE. Okay, whatever you're comfortable with. If you're comfortable with Vim text editor, it's fine for me. But what I have shown some powerful things about IDE, right? That helps you a lot. So just set up that. If you get time, do both setup. And we have seen Java program structure. So important points to remember is not public, void, all those things. Those things are not for you to remember now. Important points you have to remember is main function is the entry point. Main function is argument. You can pass arguments while running your Java code. So when you're running Java code, you will have to specify your main class file. So you can have multiple main class file. You have to specify that. Okay. And the structure looks like we have a package, we have a class, and inside class some functions are defined. Okay. And everything class functions are closed and opened by curly braces. Every statement ends with semicolon. So these are the important things you have to. I think today's class might be little complicated. It might little go over your head, but trust me, you will get each one of these terms. I have used each one of these in detail. Each and every word of the code you will understand in detail. Okay, so just have that trust. Uh, One final thing is think about this. Same thing as we did yesterday. We had few things to think. You can also apart from downloading today, you can also think about these things, or you can just learn about it in Google it. Okay. So first thing is name few reason why Java is designed to have separate components. They could have built just one. Then you would have saved some interview questions because people wouldn't be able to ask JDK, JRE, JVM differences. Okay. So why Java people when they are designing Java language, they have kept three different components. They could have done with two, they could have done with one, they could have done with four. Why three? Think about this. So everything which I teach, just think why could I why JDK, why JRE? Okay. If you think uh, these questions, find the answer to it, then you will learn a lot. That will create your that will help you increase your knowledge. That will help you ace your interviews. Okay, it's not just I will teach and you just have to remember all the things I teach and you will your interview will get cleared. No, you will also have to work. You will have to understand. I will give some assignments. You will have to do those practice. If you do all these things, you can do well. You will learn Java properly and you can ace your career. Okay. So this is one first question. Next, can you think of scenarios where you would need the JDK but not the JRE or vice versa? So if you think some few reasons, you might get answers to this also. Why do you think Java requires main methods as the entry point of a program? I told it is the entry point, but nobody asked why. So you think now, why? Why do you think it is Java needs this? So before Googling, at least think how would you have done? Okay, you might not have knowledge, but think why get try to form some assumptions and check in Google whether it's whatever assumption I have found whether it's right or wrong. So if you think that mind will get creative, that is very important. Okay, that's why I have kept this think about this section. Okay, and one exercise means it's not like you can think about this. You can just you will just have to go to Google or something and learn about it. So why is the JIT compiler important for performance of Java application? So I have discussed uh, little about this, but you can just go Google, read about it. Okay. So think about these questions, do this exercise, let me know. Okay. What you can take screenshot. Okay. So I'll give you a minute, but please give feedback on how the classes are going. Okay. And also, if you're not getting anything, please be assured that you will learn it in detail in future for sure. Okay. You can ask me when I will discuss JVM that time I didn't understand this, and this time also if I had missed something, you didn't discuss this. Can we discuss this? So I will add it in the next slide, next class, and I will discuss. It's not that I won't discuss. If you're not understanding, I will help you throughout. I will be present. Okay. Just you can message me personally also. Okay. Any doubts you can ask now. We just have 2 minutes. Then we'll close the call. I will stop the sharing. I think today there are few same students, few different students. So the students who hadn't attended yesterday's class, I think if you are in WhatsApp group, please go to the YouTube video and see the video. So you might not have gotten few things because I had referenced some parts of yesterday's class, but please go to the video, you will understand it for sure. Do tell your friends they you still have three free classes. Do tell your friends to join these classes and just experience. Sorry for the timing. We have to keep this in morning because like it's not suitable for me. But just if you do this for 1 or 2 weeks, you will get the schedule and you will wake up in morning. Okay. Some people might not feel active in the morning to learn, but yeah, just wash your face and come. You will feel active and you will learn. Okay. We both are here to learn. It's not like you are the guys. It's here to learn. We both will learn together and do we will improve our Java skill. If you want for placement, we will try for your placement. KSR will support you uh, to for placement for lot of things, making lot of things. So please tell your friends as well. Okay.